Okay, so can I start? So this is 4.2 of module 4. 4.1 we have just completed, right? So let's go ahead with 4.2. And okay, before that, those are online. Am I audible?
Yes, sir.
Okay, all right. So this is frequency distribution. Most of the things are here known, so I won't take much time here. In 4.2 module 4.2, you can see page number 251. Okay, these are some common terms like we use telemarks. I think you know that. Just give me a reminder. This telemarks. Do you remember? We take it like this. When there are 5, we make a bundle. So just how to represent, how to get a frequency distribution table using telemarks, telebars or telemarks. Okay, so those distribution tables we know how to make it. Frequency means, for example, here in this PDF, frequency means if against each data, whatever a number occurring, that is only the frequency. For example, in this table, you can see 1 to 2. Suppose there are 5 children, so these 5, 6, 3, 6, these are the frequencies. All right. Then these are very common terms which you again got it in the other classes. Discrete frequency distribution, I'm going to show you what is that. Then how to construct a frequency distribution table. All right. Then data, that day we discussed primary and secondary data, similar sort of data, raw data and continuous data here, right? So these are basic definitions you go through once, right? It's not that difficult to get the answers. Then I'll be explaining now what are class boundaries, okay? And few things we'll be doing here. Class magnitude, what is a class magnitude, right? So exclusive or continuous series, inclusive series. So these things are known to you, all right? Then how to get relative frequency, how to get percentage frequency, okay? How to get frequency density. So those things now I'm going to cover. Then I'll be coming to the graphical representation. So here only few terms I'm going to cover right now. Okay. See, you must have come across this type of tables. You don't have to make it now. Suppose, just a minute. Okay. So you must have come across these sort of tables before, I believe. So when you have a table like this, these are the suppose ages. These are the ages in years. These are the suppose number of students or number of people. All right. These are the number of people. All right. So just one second. Now suppose it is like 0 to 10. Done. Don't have to write it. Just you look at the board. Then 20 to 30, 30 to 40, 40 to 50. So these are the ages. Suppose in the age of 0 to 10 years, in the unit suppose years, so we have suppose 5, here you have suppose 6, here you have suppose 10, then suppose 8, and suppose here again 4. So when you get a table like this, and here we used to have telemarks, which we have, I didn't do it. Here we used to have telemarks. So telemarks are here 5 people, then we used to make it like 1, 2, 3, 4, then 5, yes or no? 6 if it is 1, 2, 3, 4, 5, then 6, then 5, then here 1 outside. So all these are known to you, right? Now Here, class boundaries, few definitions we need to know because we will be doing this after a few days in the other chapters. Class boundaries, we have learned like lower and upper class limit. Lower and upper class limit. So, lower and upper class limit. These are actually the class boundaries. Now, class boundary means, this lower limits means in each class, you know, these groups are called classes or class intervals. In each class, this smaller number, whatever is there, so this 0, 10, 20, 30, 40, the smaller number is called lower class limit, and these bigger numbers are called upper class limit. So this is actually, it's given here like class boundaries, right? So now, if and this table is a continuous table, continuous data. Continuous data means this table 0 to 10, then that number starts with 10, 10 to 20, 20 to 30. So this is a continuous data. If not continuous, it occurs like this. If not continuous, suppose the same sort of table. Okay, so if it is like suppose same question, suppose age, and these are number of people or number of persons. Now, if it occurs like this, suppose 1 to 9, then 10 to 19 maybe, okay, or suppose it is 20 to 29, 30 to 39, and so on. So here this is also a class, these are also classes, class intervals, but this is not continuous as shown in the previous slide, because this is 0 to 10, wherever it ends, it's the other one starts from here only. So this is a continuous data. But now this is not continuous, but it can be made continuous. Okay, how to make it continuous is very simple. We will be doing also in the exercises. So whatever this lower, whatever this lower limit we have and the upper limit, in the lower limit we just have to subtract, in just lower limit we just have to subtract 0.5. So from here we will be subtracting 0.5, and in the upper limit we just add 0.5. Then it becomes continuous, you can check it. If I subtract here 0.5, this one will become suppose 0.5, and under upper limit 0.5 added, so how much? 9.5. Now 0.5 subtracted here, so how much? It will be 9.5, and here 19.5. So 0.5 subtracted from 19.5, and this is so on. So with this, after doing this, we have seen the data again became continuous. So if data is not continuous, you can still make them continuous by doing this calculation. Now why this 0.5? Why 0.5 we need to take? Why not 0.6? Why not some other numbers? So this is very simple. From 10 to 9, what is the gap? 1. So 10 minus 9. Even here also, what is the gap? Every time 1. So one gap, that gap to be divided by 2. How much? 0.5. That is the number from where this 0.5 has come. So so this is all about classes and class limit, which I said upper limit and lower limit. Now there is another one, class width. Class width means class size. So class width means class size. For example, here class size means this, how much the class size bigger is, that is the class width or class size. Just subtract this, 10 minus 0 or 20 minus 10, upper limit minus lower limit, 30 minus 20. So what is the gap? 10 gap. So this 10 is only the 10 is called class size, or you also call class width. Okay. Then few terms which you may not know directly or have some confusion on these terms. Then this is what I said just now, actual class limit or class boundaries. So what you have to do, I told you, minus half of the gap, that's what I said just now, upper limit plus half of the gap. So in the upper limit we add 0.5, half is that 0.5, and in the lower limit we subtract that 0.5. Okay. So the examples are also given, but already I have showed you with 0.5. They are writing with the help of half. Okay, the same thing. I'm coming to this. No, not same. So just now you have discussed the class width. Okay, so let me come to his question. We have discussed just now the class width. Okay, so class width, it is also called class size. But he is asking this range is same, is this or what? No, I'm coming to that. No, not same. I'm going to say what is the range. But class size is clear now. upper limit minus lower limit. Now range is, this is also there, okay? So to get a range, suppose you have some data, 0, then 10, suppose 12, then 5, suppose 9, okay, 18, suppose 25, then suppose 2, suppose 15, suppose 95, okay. So these are some random datas, suppose 56, so these are some random datas. Now the here range is very simple, range is the highest observation minus the lowest observation. So highest observation means in this, suppose these are the marks obtained by you in an exam or in a test. So out of this, who got the highest and who got the lowest? Their differences only, we need to find it. So here the highest observation is 95, the lowest one is 0. So if you subtract it, this is only the, so what is the definition then? Highest data or highest observation minus lowest data or lowest observation. Is it okay? This is the range. Now coming to some more definitions. Class mark. So class mark or midpoint or mid value. So here I have already this table. So class mark means, class mark, just a minute, let me take the eraser. So I'm going to discuss once again the class mark, how to get the class mark. Ready? So class mark is just the upper limit and the lower limit we need to add it. For example, I had here, okay. So suppose I have 0 to 10, 10 to 20, 20 to 30, 30 to 40, and I had 40 to 50. Now the class mark is the middlemost value here in each class. So what is that? 0 and 10, just to add it. 0 plus 10, how much? 10, just divided by 2. That means lower limit plus upper limit divided by 2. So if I show it here, for each class it is the same. So it is lower limit plus upper limit divided by 2. So in each class, suppose if I try to find here, what is the lower limit here? Lower limit 20, upper limit 30. So 20 plus 30 whole divided by 2. So it will be 50 by 2, how much? 25. And with this you can see this 25 is actually the middlemost value from 20 to 30. So the class mark simply refers to the middlemost value of a particular class. Done. So just a minute. Just 1 minute. All right. So this is what class mark we also call midpoint. We also call it mid value. Done. Now class magnitude is the class size only, upper limit minus lower limit. Okay. So this is what the basic definitions. Now I'm going to explain something here which is relative frequency, how to get it, how to get percentage frequency, how to get frequency density, and these particular terms. And here even question comes directly, you need to find this relative frequency, then percentage frequency and frequency density. Easy definitions, not very difficult. I'm going to show it once. You can write this question now. All right. So write this question. Question 1, suppose find right. Find the, sorry, just a minute, when it's not visible. Okay. Find the frequency density So only these terms will be doing. Find the frequency density, then percentage frequency and relative frequency. Okay. So find the frequency density, relative frequency and percentage frequency for the following data. Frequency for the following data. Okay. Now, so if you make a table here, okay, make a table everyone. This is what the question is. I make a easy data so that you can all do it easily. Suppose these are the classes, or we say class intervals, and these are the frequencies. These are the frequencies. Okay. So take a easy class, for example, 10 to 20, 20 to 30, 30 to suppose 40, 40 to 50, and suppose 50 to 60. And the frequencies are here, suppose 2, this is suppose 4, suppose 10, suppose 6, and suppose 8, and suppose 6. These are the frequencies. Okay. Now I asked the question how to find the relative frequency, how to find frequency density and percentage density. So let me start with relative frequency. Okay. We are just trying to find one by one. So here let me show you how to find relative frequency. So how to find relative frequency. Can you understand handwriting? So we are going to find the relative frequency. Done now? Now, if you see, the relative frequency means the relative frequency is given there also. The class in frequency divided by, so relative frequency is just the note you need to follow. Relative frequency is just the class frequency to be divided by total frequency. To be divided by total frequency. Getting it? So the class frequency, whatever frequency, individual frequency is there for the classes, it's to be divided by the total of all the frequencies. That means, if I show it here, first you need to get the total of these frequencies. So if you find the total of all this, if you find, sorry, just a minute. If you find the total of all this, just to find the total of all these frequencies, so you can see this is total is 30, right? Total is 30. Yes or no? Now, relative frequency, if you try relative frequency, this is the formula, class frequency divided by total frequency. So the class frequency here, class frequency, what is the class frequency here? 2 by total frequency, how much? 30. So 2 by 30, just you need to get it, it's 1 by 15, this is the class, or you can convert it into decimal. Getting it? This is what relative frequency. So once again, if I show it one for one, suppose 4 here, 4 is the class frequency to be divided by total frequency, how much? 4 by 30. If you convert, it will be 2 by 25. Is it okay? One more, sorry, 2 by 15. So 2 by 15. Now the other one, suppose here it is 10 by how much? 10 by 30 total frequency, so it will be 1 by 3. Like that, do the other two, 8 and 6, right? So we can write it in decimals, and here I think it will come non-terminating, non-recurring. So I kept it in fraction. Seeing the question, what actually requires, we find it, right? Now, percentage frequency is the same almost, but we need to get it in percentage. So here if I show this, now if I talk about percentage frequency, it is the same thing, class frequency divided by total frequency, but since it is a question of percentage, it has to be multiplied by 100. Getting it? So percentage frequency is class frequency by total frequency to be multiplied by 100. as you have seen just now, okay, before that, so how much you got it? 8 by 30. Is it 4 by 15? Yes or no? And this is 6 by 30. How much? 1 by 5. So these are the relative frequencies. Now if I try the percentage frequency for all these data, so percentage frequency, it is the same thing, frequency by total frequency. So class frequency is 2, total frequency is how much? 30 multiplied by 100. Why 100%? Getting it? So if you now cancel these zeros, 0 got cancel, what is that? 2 tens are 20 by 3. So you can convert into decimal, 6.666 like that it will come in percentage. Done. One more. So frequency here it is 4, class frequency, total frequency is 30 to be multiplied by 100. Okay, get it? So this is 40 by 3. You can convert into decimals and get the required values. Complete this table. And the last one is frequency density. This is slightly different. Okay, different, not difficult at all. It's different, but not at all difficult. Okay, so frequency density is over. Now we are going to do it relative frequency. Frequency density is not done. Okay, frequency density done. So frequency density goes like this. Frequency density. If you know the finding, you can, without by hearting or remembering the formulas, you can get this side. So frequency density is class frequency by class frequency divided by class width. Class width means class size, which I told you a few minutes back how to find it. All right. So the last term I'm going to find here is frequency density. It's a class frequency to be divided by the class width. Can I start? Now here, this one, frequency density. So I hope you have completed these two. Now frequency density means it's the same, class frequency. What is the class frequency? 2. To be divided by the class width. Class width, I just show it once again. To be divided by the class width. Class width means class size. And I told you class size, how to find it. Upper limit minus lower limit. So 20 minus 10, how much? 10. So every time, how much? So all these classes are of size. The difference, how much difference? 10. So by these numbers, just you have to do it. So it is 2 by 10. 2 by 10 is 0.2. If I convert in, decimal. So how to get it? So one more. Suppose this is class density is this class frequency is 4 to be divided by the class size. How much it is? 10. So how much? 0.2. So like that, we can also find the frequency density. Is it okay? Done? So it's to be divided by the last one, frequency density to be divided by the class size. So we have divided by 10 every time. Okay. Now coming to the next topic. Is it over? Can I go to the next slide? So with this, your module 4.2 is over. With this, module 4.2 is over. This I just showed you all this relative frequency, percentage frequency, and frequency density. I just showed this how to calculate or find this for any given data. Right. Now coming to the 4.2 is over. Now 4.3, if I start with, this is all graphical representation. As I told you in the last class that construction of graph doesn't come always. Do you remember this? We have discussed pie chart or circle graph. It was discussed in the last class. Getting it? So I'm going to start this with histogram now. I repeat, I have already discussed this circle graph in my last class. Do you remember that? So we have to get a central angle, right? So I am not going to discuss it again. It is already being done. Now I am going to discuss here the construction of histograms. Okay, and there are different types. Getting it? So histograms looks like these or some other sort. Okay, so let me do one by one. I just start the very first question on histogram. So it is module 4.3. Done. So just a minute. Question, suppose construct a histogram for a given data. So this histogram is the quite common and simplest histogram. Getting it? So this is type 1 actually. Type 1. I'll tell you what is the type 1. So if I do it, I think you all are aware of this. You must have done it before. As I told you, this is the simplest of the histograms. So here classes, here are frequencies, and suppose this is I start with 80 to 90, all right, 90 to 100, 100 to 110, 110 to 120, and suppose 120 to 130. So these are suppose 8, 9, suppose here it is 12, then 5, suppose it is 4. Now the histogram is to be constructed, it's almost in the sort of bar graph actually. So to construct the histogram, as we know, we consider the x and y axis. So this is the x axis, here y, this is 0. Now look at the board. These classes, whatever the classes we have, they are always represented along the x-axis or the horizontal axis. The frequencies are always shown on the y-axis. Okay, I hope you know this already. Now, if I show first of all the frequency, these are quite smaller numbers, 4, then 5. The highest one is 12. So we can directly go, 1, 2, 3, 4. Okay, we can go like this. 9, 10. Suppose 11, and suppose this highest one is 12. Now here it starts with 80, so it starts with 80, so 80, 90, then 100, then 110, the last one is 130, 120 and 130. But while doing this, you can see here, so it was 80, right? Now while doing this along the x-axis, you see these units. This unit, what is the gap here? 10 gap here. So all these gaps are 10. All these gaps are 10, but the same unit here the gap is more. What is the gap? 0 to 80. So in that case, we are actually taking this equal portion. We are taking equal portions, but here all the gaps were 10, but this gap is more than 10, 80 gaps. So in that case, I hope you know already that we use a broken line like this, which is called zagged line, or it is also called king, K-I-N-K. It is called zagged line as well, zagged line. Okay, it is also called broken line. So this broken line we use when we skip some data actually. So when some data are skipped or some data are not shown on that, which is actually quite large. So in that case, we use this broken line, right? So the broken line is to be used like this. And then we write here scale and all. So this also I think it's known to you. X-axis and then y-axis, we mention the scale separately. So x-axis, it is the x-axis. Other than the king, remaining all the scales are 10. So we are taking 1 unit equal to 10. Here, each gap is 10. But y-axis, the gap is taken as how much? 1. So along y-axis, the 1 unit equal to 10, right? So that everything is ready to plot it now. 80 to 90, it is 8. So 80 to 90, it is 8. Just to go draw a rectangle like this. 80 to 98. 90 to 100, suppose 9. 90 to 100, suppose 9. I'm just drawing a rough one. Then it's 12 from 100 to 110. So it is 100 to 110, suppose 12. Then 110 to 125. 110 to 120 is 5. And then 120 to 130 is 4. Now, what you have seen, this is almost in the pattern of bar graph, but unlike bar graph, this time the bars are attached to each other. When you drew bar graph, all the bars are separate from each other. Do you remember that? But here, all the bars are attached to each other. Okay, so actually the reason is why they are attached to each other. Even the data is, repeated. So it's ending at 90, but starting at 90 in the next class. So when it happens, the bars becomes attached to each other. That is why the histogram comes like this. All right. So as I told you, this is type 1, the simplest one, where no modification is required. The classes are already continuous. Okay, and we just plot them according to the frequencies and get the histogram like this. Right. Now coming to the other types. So coming to the other types. Okay, so look at this histogram. Type 1 discussed in the last class. Actually, I made it before. So this, what I have discussed just now, it was type 1. Now coming to type 2. Okay, we have 2-3 different types. So this is the type 2. I'll show you what is the difference here. If you look at the data that I have given here, you will understand the difference even by your own. Now to see that, you see a random, suppose question number 1. You don't have to write it, I'll be sharing in the group. So you'll get this PDF. So don't have to write it now, just to try to understand. A random survey of the number of children of various age groups playing in a park was found as follows. The question is, you have to make a histogram on this. Now, to make it, the difference here is, okay, the difference here is, it is 1 to 2, all right, this 1 to 2, 2 to 3, 3 to 5, 5 to 7. So what you can see, 1 to, these numbers are same. That means it is a continuous data. We don't have a doubt on this. It's a continuous data. But what is not same, the class sizes are not same. If you do 2 minus 1, how much? 1. If you do 3 minus 2, 5 minus 3. Yes or no? So here again, 7 minus 5, 10 minus 7. So 10 minus 7 is 3. Then this is your 5 and 17 minus 15, how much? Class sizes are unequal. So the difference is very clear now. In the last one that I did few minutes back, just a minute. Yeah. So in the last one that I did few minutes back, you see we did not have such problem. Here all the differences were how much? 10. So it was a continuous data with equal class sizes. That is what I said type 1. Continuous data with equal class sizes. So construction of histogram is really very simple. But now, if I come to this, data, as I showed just now, the class sizes are here unequal. The class sizes are here unequal. So we need to modify the table. Table modification is required. Okay. Now, how to modify the table? For this, this is the table which I have showed here, and then I'll be plotting it there. So plotting, you can do it yourself. Now, to modify the table, modification is required. Okay. To modify this table, what you have to do here is, these two are already given in the question. First, you have to find what is the class width. Class width means class sizes. So as I have discussed, 2 minus 1, 1, 3 minus, so you know upper limit minus lower limit is the class width. So 3 minus 2, as you know, 1, then this is 2, this is again 2, 10 minus 7, okay, then this is 5 and this is 2. Done. And now the rule is that we need to find the frequency density, which I have discussed few minutes back in module 4.2. Now frequency density means frequency by what? Class size. So what is the frequency here? Frequency how much? These are the frequencies? Yes or no? So frequency by, I just write it in this form, frequency by class size or class width, how much? 1. So this is 5 by 1 is 5. Then here frequency is 3, 3 by 1, 3. Then frequency is 6 in this, class width how much? 2. So 6 by 2 is 3, 12 by 2. So frequency is 12, class size is 2, how much? 6. Frequency is 9, class size is 3, how much? 3. Frequency is 10, class size is 5, so it's 2. And then frequency is 4, class width is 2. These are the frequency densities. Now, what you need to do here is, if I go to the next, it will get erased. So now for all these 1, 2, 3, 1, 2, 2 to 3, 3 to 5, we have to plot or we have to show only these values along the y-axis. Getting it? So the numbers you see 5, 3, 3, 6, 3, 2. So we have to show these values, okay, or these frequency densities along the y-axis. Now when the class sizes are unequal. Getting it? So if I now go it there, just a minute, it will get erased anyway. So if I now go to this, you'll try this at home. If I go to this, so what you'll be doing here, this will be your y-axis, this is your x-axis. So these are the ages were already shown here up to 15. So this 0, 1, 2, 3, 4, 5, up to 15. Sorry, up to highest one is which one? Up to 17. And here you will do 1, 2, 3, 4, whatever. Suppose it is up to 10. Now I just want to make you clear, whatever the frequency you got it in the last column, by dividing what? Frequency by class size. That value is only to be plotted here. Could you understand? Now you can see, although I have drawn rough, what I did here is I made some of the changes in the classes. So I drew it like this. For example. Okay. So here why does it happen? Why this? It will come in this form. Because it will come in this form where you don't have to subdivide. You don't have to subdivide like this. You don't have to subdivide. The reason is why it comes like this, because of the class sizes. Okay. So class sizes are unequal. That's why some rectangles will be coming bigger, some rectangles will be coming shorter or smaller. So for your better idea, if you have doubt, you can see page number 260. You can see page number 260 in your model. So this is type 1. Look at this here. It was type 1. Now it was type 2, in which you see the bars. Okay, the bars are coming what? Of unequal breadth. This is much bigger in breadth. This is much smaller in breadth. So this happens only because of the unequal class sizes. Is it clear? Is it okay? It happens because of the unequal class sizes that I showed you here. These classes are unequal. So that happens because of these unequal class sizes. We get the rectangles of different width. So if somebody has joined today, you please keep a note, we don't have to construct. That is actually not in our syllabus. Construction is not there. But we should know the topics, each and everything, so that based on this, the question comes. So we don't have to construct as it is. Getting it? Now look at this. Draw a histogram for the following frequency distribution. So this is type 3 of histogram. So the difference should be clear. And I hope now by this time it's clear. The difference here is what? The classes are not continuous. Not continuous means, you see, this is 13. Here it is 13, but this number is 14. So the classes, here the upper limit is 13, it ends at 13, but the next lower limit starts with what? 14. So this, let me see the gap. 13 minus 10, how much? It is 3. 18 minus 14, how much? 4. 25 minus 19, how much? 6. So even the class sizes are also not same. Not only the classes are not continuous, class sizes are also not same. So this is a question of combination of two different topics. So one is unequal class size, other one is discontinuous classes. So what you have to do is, here it is shown. And as I told you, you don't have to draw it. I will be sharing this PDF in the next class because some more topics to be covered. Now, what you need to do, first of all, since the classes are not continuous, I believe everybody understood what is I'm saying not continuous, not continuous. They are not the same number. They are not the same number. They differ by how much? 1. So, since they are not the same number, we must make the classes continuous, which you have already discussed. Can you tell me how to make it continuous? What to do? In the lower limits, 0.5 to be subtracted, in the upper limit 0.5 to be added. So here 0.5 subtraction, here 0.5 addition, right? Now if you subtract 0.5 from each, and I told you from where this 0.5 has come, the gap 14 minus 13, this is 1 by 2 is 0.5. Now in the lower limit, if you keep on subtracting this 0.5, so this will be 10, then 9.5, then it will be 13.5, this will be 18.5, this is 25.5, 33.5, this is 37.5, and this is 45.5. So here we subtracted the lower limits. Now on the right, that means in the upper limits, just 0.5 you added. So this is 13.5, addition here, 18.5, then 25.5, then here 33.5, then 37.5, then 45.5, and this is 50.5. And with this, you all can see the classes have become right now continuous, because this is 13.5, 13.5, 18.5, 18.5, so on, right? Now, why this second part is to be done? The second part is to be done because not only it was discontinuous, it is also having unequal class sizes. Unequal class sizes means 13 minus 10, how much? 13 minus 10 is 3. But now the class sizes you have to get it from here. Please keep a note of this. Because we will be plotting this particular portion. This particular portion will be plotting. So you don't have to, this is now became old data. We have made a new data. So from this new data only the class size you need to get it. Now class width or class size is upper limit minus lower limit. So it's 13.5 minus 9.5, how much? 4. But if you do it here, how much? Are you getting my point? 3. Why this difference? Because 0.5 subtracted, 0.5 added means as a whole 1 got the difference. Difference of 1 has occurred. So anyway, we don't have to do it from the old data. We need to do it from the new class intervals with the new boundaries. New boundaries means this new lower limit and the new upper limits. Now here you subtract 18.5 minus 13.5. How much? Keep saying this is 5. Then I think 7. Then I think it is 8. Then 4. Correct? Then it is 8 again, 8. Yes or no? And then it is 5. So these new classes sizes we are getting it now. Once again the frequency density to be found. Now you can have a question, why this frequency density? Reason is very simple. The class sizes are not equal. So since unequal class sizes, we need to get the frequency density. The type 1, we did not find frequency density. Why? Because the class sizes were already same, right? So frequency density, as you know, I won't explain much now. So frequency density is here 5, f by h, no? So 5 divided by 4. So if you convert, you will convert into decimal. So if you divide 5 by 4, and before I continue, you know your exams calculator will be allowed. Okay, in your exams, maths paper, all of you keep a note. Maths paper, ordinary calculators, not the mobile calculators, not the scientific calculators. Ordinary calculators are allowed. So you all can do the calculation using calculators. Okay, in exams, you don't have to do it manually. Ordinary calculator, but not the scientific one. So 5 by 4, if I do it now, 5 by 4, it will be like I think 1, yes or no, 4, then 1, 0, then 0.0, 4, okay, then again, am I correct? 2, so it is 1.25, right? So similarly, here, frequency by class size, that means 3 divided by 5, so it will be 0.6. Is it okay? Then what is that? Frequency is 6 to be divided by 7, get the decimal. So all this you need to get it now. Finally, this table is there, but if I scroll down, it will get, this data will get erased. So I'm just showing it here only. When you now plot it, actually this table is here. This is the table, but scrolling it will erase the data. Now when you plot it, all these class boundaries to be plotted here. All these class boundaries to be plotted along x-axis. That means this 9.5, yes or no, 13.5, then what, 18.5, all these to be plotted here, and those frequency density to be plotted here. Then we get a histogram, where all the bars will be attached to each other. Getting it? I repeat this line, what I'm saying, all the class intervals with new boundaries. That means this data, let me change the color. So all these to be plotted here, and all this frequency density that you will get it, you have to go for the actual length of the bars. Is it okay? That means your this column and this column is to be plotted. Is it clear? Is it okay? So which to be plotted? The class intervals, this is along x-axis. This is along x-axis. The frequency density, this is along y-axis. So rest of the things are just for rest of the columns. It was the old data. This is also a old data which you have modified, right? And this one, we just found h to get the calculate the frequency density. So these data to be plotted along x-axis. This is to be plotted along y-axis. All right? Could you understand? So when you do it by your own, this table will be there. I'm sending it, as it is PDF. So you will complete the table the way I have explained, and then even I kept a space for frequency, construction of the histogram, so you can do it. Now these class intervals, I repeat again, this class interval that will be doing, these class intervals, and this frequency, actually this will be frequency. This is, although I have written frequency, actually it is frequency density. And this class interval is not the old one. Which one? The new one. New one means with that lower and upper limit. Getting it? Where we made it continuous. Is that clear? Okay. So with this, the histogram is over. So I'll be doing the next frequency polygon and some other topics which are there in 4.3. So histogram is done. I'll be starting next day. Our module 4 will already be over. We'll be starting 5 after a few days. Okay. So after one class, not actually after a few days. After one class, we'll be starting the module 5. So here we have frequency polygon. I think we have OSIF. Let me check it once. So we'll be doing the next day this one, OSIF to be done, or cumulative frequency distribution curve. Okay, less than and more than type. So then I'll be able to start module 5. Okay then, thank you. Thank you all.